what Tyndall is doing in the FAMES pilot line, and it's around this topic of vertical power. And increasingly, we are finding, let's say, maybe the data center AI engine is a perfect example where typically you're using point of load DC-DC converters, many DC-DC converters, with many voltage rails going into a processor. And the losses that arise between going from these point of load DC-DC converters to the processor, especially if you think about AI engines where you're talking about 1,000 amps and they're talking about going to 5,000 amps into something that's less than 1 inch square, the losses are enormous, traveling a centimeter or more. So the idea of vertical power would be, can we put the DC-DC converters, and can we put arrays of DC-DC converters underneath the processor, and so that the current is now only traveling perhaps a millimeter or less. One of the biggest issues about doing that is DC-DC converters, they have these things called inductors, large wire wound entities. If we could do power supplies without magnetics, the world would be a better place. Many people would say capacitors are the way to go. We have spent maybe 20 years or more trying to make them disappear, and the idea is, can we put them onto silicon? And what we are really doing is we're using magnetic thin film technology, which has come from the disk head industry. How can we go from this size down to this size? What we have to do is we're relying on a much lower inductance, and we need to go way up in frequency. So going from 1 to 5 megahertz away up to perhaps 25 to 100 megahertz. We use this phrase MagIC, making magnetics disappear onto ICs. You could say it's following Moore's law. Moore did it with transistors, we're doing it with magnetics.